Welcome back. The objectives of this video are to explore finding terms of a geometric sequence. So we'll have to write the equation for the sequence and find a particular term. And then we're going to do some sample problems and application problems of geometric sequences. So let's kick right off here with example 10. Find the indicated terms of the geometric sequences. So we have to find our ratio, and our common ratio here, -15 divided by 3 is -5, and our first term is 3, so our formula a sub n is 3 times -5 to the n minus 1. And we want to find a sub 6 and a sub n. We've already found a sub n, so now we want to find the sixth term. A sub 6 is 3 times -5 to the 6 minus 1. 3 times -5 raised to the 5th power. I'm going to need my calculator for that. I'm going to raise -5 to the 5th power, and I get -3,125. I multiply that times 3, and my sixth term is -9,375. You could probably eyeball that without even using your calculator. Sample B, determine R and a sub 1 for the geometric sequence. They give us a sub 4 is -8 and a sub 11 is 1/16. So this is going to be a little bit more challenging. Let's think about this for a moment. Let's go ahead and write down our general formula. A sub n equals a sub 1 times r to the n minus 1. So if we had the first term, that's what we would use. But now we have the fourth term and the 11th term. So we can just say a sub 11 equals a sub 4 times r to the 11 minus 4. And I have the fourth term and I have the 11th term. So I can say 1/16 equals -8 times r to the 7th. Now I have to do a little algebra to calculate r. If I divide both sides by -8, or multiply both sides by -1/8, I get -1/28 equals r to the 7th. And I can take the 7th root of both sides. So now I know that r is equal to the 7th root of 1 over -128. I may not know that in my head, but it turns out that r is equal to -1/2. So now that I know my r is -1/2, I can use one of these two. I think I'm going to use a sub 4 and plug it back into my formula. I can say a sub 4 now is equal to a sub 1, the one I'm trying to find, times my r that I just found out, -1/2, to the 4 minus 1. So I'm doing the same thing I did here in part 1 where I solve for r, but now I'm solving for a sub 1. I just haven't put in what my a sub 4 is yet. So I know a sub 4 is -8 equals a sub 1 times -1/2 to the 3rd power. -1/2 to the 3rd power is -1/8. So I have a sub 1 times -1/8. I multiply both sides by -8, and I get positive 64 equals a sub 1. So my first term is 64. In sample 11, we've got a radioactive substance decays. The amount remaining will form a geometric sequence when measured over constant intervals of time. So the table, incomplete as it is, shows the amount of unknown substance initially and after 2 hours. We need to find 1 hour, 3 hours, 4 hours, round your estimates to the nearest gram. So in order to find the R, we need consecutive values here, and we don't have that. So we've got our formula, though, from an earlier video that says how we can find one in between, and that is that square root formula. So let's go ahead and find the mean. And that was by b is equal to the square root of a times c. So this is going to be our b value here. So what we want, b is equal to the square root of 1,320 times 384. You're going to have to trust me when I say I put that in my calculator. I can't do that in my head. And I get b is approximately equal to 711.75. So we're going to call it 712 for our purposes. So then our R value is 712 over 1,320. Putting that into my calculator, we're using an R of approximately 0.539, and the 39 is repeating. So that's the second thing we've done. Now we go on to the third thing, and we have to find a sub 3 and a sub 4. So a sub 3 will equal 384, because our ratio is the same, times 0.0539, repeating, raised to the first power. So a sub 3 equals 207.13, or about 207. And then a sub 4, we can do the same thing. We can use our 207 and then multiply that by 0.539, repeating, and that's 111.65. In sample 12, you're offered a starting salary for your first year at $37,500 with annual increases of 5% each year. This means your salary will be 1.05 times what it was in the first year. What would you expect to earn in the fifth year of your job? So this is going to be 5 1.05s. So your first year is going to be 37.5, and then the next year would be 37.5 times 1.05. I put my decimal place in the wrong spot. And so forth. So your third year would be 37.5 times 1.05 to the second power. So that means this fifth year, a sub 5, would be 37.5 times 1.05 to the n, but minus 1, right? Because the third year was raised to the second year was raised to the first, so the fifth year it's going to be raised to the fourth power. So a sub 5 equals 37.5 times 1.05 raised to the fourth, or putting it in your calculator, $45,581.48. In sample 13, a Christmas tree farm has 10,000 trees on its property in 2022. Each year after, 10% of the trees are harvested. So that means the subsequent year will only have 90% of the trees there. And then subsequent year will have 90% of that. So write a general formula that gives the current number of trees on the farm in year n, where n equals 0 corresponds to 2022. And as I just said, T sub n is equal to 10,000 times 0.9 raised to the n, because where n equals 0 corresponds to 2022, so that we don't have to do the n-1 business to get the first year. And then it says use the formula to find the number of trees in n equals 1, 2, 3, and 4. What is happening to the rate of change of Christmas trees over time? So here I show the formula for each one. We're doing 90% of the trees each subsequent year, so our trees are decreasing by 90% per year, and those are the values of the trees in each particular year. So in sample 14, a ball is dropped from a height of 30 feet. Each time it hits the ground, the ball bounces back up, but to only 80% of its previous height. So that means each time the ball bounces back up, it's only gonna bounce 80% as high as it was the last time. So complete the table below to model the data in the scenario. Round your height to the nearest hundredth. Well, let's come up with a formula that'll make this a little bit easier to do. So if we do like our Christmas tree example, a sub n equals, it's 30 on the first one, but then each subsequent one is 80% of that, and then n-1. So if we put n as 1, our initial height is 1, 30 to the 0, or 80 to the 0 power is 1, we get 30, and then a sub 2, and so forth. So a sub 1 is going to be 30, and a sub 2 will be 30 times 0.8 to the 2 minus 1, so 80% of 30 is 24, and then 80% of 24 is 19.2, and 80% of 19.2 is 15.36. So this is what they mean by you can find the next one recursively. So we're just going to multiply by 80% all the way across here and get our particular values. So this is kind of what it looks like with our ball bouncing. So we start at 30, then after 1 it's going to be 24, 19.2, 12.3, 9.8, and so forth as it bounces less and less high as it continues to go along. How many times will the ball need to strike the ground before its bounce is less than 1 foot? Well, we could keep going and just write all this out, but what we're going to do here is I'm going to go ahead and use my calculator, and I'm going to input the formula into my calculator. So I'll have a y sub 1 equals my original formula, and then y sub 2, well, less than 1 foot, I'm just going to call that 0, and we'll graph y equals 0, and we'll see where they intersect. We're actually going to graph y equals 1 because we want less than 1. So I zip over to my calculator and I input the 30 times 0.8 raised to the x minus 1, and then I input y equals 1. Now I'm going to steal my window again from my data. Okay, so my x values are going to run from, well, I went from -5 to 20 for my number of times it bounced. And I counted by ones, and my y values, I went from -5 to a y max of 35 because it started at 30. I just wanted to see something bigger. Okay, so that was my window, and I hit graph, and now I've got a nice graph of that formula, and then I'm going to find the intersection. So second calc, use the intersect key, which is 5. Okay, select my two curves, make my guess, and I get an intersection of 16.24. Which means the ball will have to bounce 17 times. What is the total distance the ball travels in the first 10 bounces? Note, be sure to consider the behavior of the bouncing ball. And I think they're asking for just like the vertical distance here. So when it drops 30, but then when it goes up to 24, it also goes down 24. And then when it goes up 19, it also goes down 19.2. So our equation is going to be 30 times, or plus 2 times 24, plus 2 times 19.2 plus 2 times 12.3, so on and so forth, 10 times. So adding all of those up, I get 244.18 feet, different than what Gene Adams says because it asks for the first 10 bounces. Well, the first 30 feet, it hasn't bounced. It was dropped. It doesn't bounce until the beginning of the 24 feet. So our first bounce is the 2 times 24. The second bounce is the 2 times 19. So I think she missed one of the bounces. She stopped at 2 times 4.03. So that's our introduction to geometric sequences, and we'll get some more practice with that when I see you in class.